Welcome to this multi-part video series on how to use ROBOTC to program the NXT Mindstorms robot. Now I understand that for those watching this video, you may have varying skill levels. Some may have had previous experience with programming languages and merely aims to understand how to work ROBOTC and how to communicate with the robot, while others may have no experience whatsoever and requires assistance with the bare basics. Now, I admit, for first timers, programming can be a very daunting task, but trust me on this. When you start to work with it, when you start to actually understand it and get to know it and actually write a couple of programs, at first it'll still appear foreign and obscure, but with time, what once looked extremely strange and didn't make any sense will become crystal clear, and you'll wonder why you ever were confused about the subject at all. This video aims to teach you how to set up your ROBOTC program, as well as provide a very basic guide to programming itself. More detailed discussions will feature in the following videos. By now, you should have set up the ROBOTC program. If not, you're going to need to download it. The link in the description of this video takes you to ROBOTC website to download ROBOTC 3.0 for LEGO Mindstorms. Make sure you have this version. Do not get the later 4.0 version. That is unsupported and you should not be using it. You should make sure you have the 3.0 version. You can, if you've already installed and you want to make sure, just go to Help, About ROBOTC, and it should appear down here. This is version 3.65. That'll be fine. So if you've clicked on the link, and if you haven't downloaded it already, of course, then you should appear to a page like this. Just click the button, download the program, set it up like any other program, and run it. You should get a page like this. Now here's where things start to get a bit tricky. By default, ROBOTC comes unlicensed, meaning you can't use it. You need to install a license. Now by default, ROBOTC lets you get away with a 10-day trial that you first need to activate. But if your 10-day trial has already expired, you're going to need a key for it. Thankfully, your course coordinators should have one. Just email them about the subject and they should give you a key back, a collection of letters and numbers to activate your program. To activate it, go to Help, Manage Licenses, and so it should appear here. You just go to Add License, select the product. You'll need to select LEGO Mindstorms 3.0, and then put in the license ID as well as the password. Of course, it's been masked here, so you can't use this one. However, you should be able to get it from your course coordinator. Then activate online, wait a bit, and it should be good to go. If you don't want to use a license, just do this again, but don't enter any values into license ID or password. Just click Start Trial and you should get a 10-day trial. Plenty of time to do whatever you need to do. Now we have to set it up to work with the NXT brick itself. Now, unfortunately, NXT bricks, the operating system loaded onto them doesn't work well with ROBOTC. So first we need to completely overwrite this OS and install a new one that works better with ROBOTC. Now, I understand that may appear to be a very difficult task, but trust me, it's a couple of button clicks. Very easy to do. Just take your NXT, insert the USB cord into the NXT on your computer, then go to Robot, Download Firmware, Standard File. Now, it should appear here. I don't have an NXT brick available with me right now, so I can't show you this, but follow the steps I do and you should be fine. So you just click here and then go to Firmware Download, FW Download. That just click on it, wait a couple of seconds as it installs the operating system, and then you should be fine. It should be done. It should pop up with a dialog box saying, hey, you've done. So then click Close, And then we've got one more thing to check. Just go to Robot, Compiler Target, Physical Robot. Ensure that is pressed. That ensures that when the program is written and ready to run, it actually gets installed to the NXT, which I'm going to talk about now. When you write a program, it appears as various lines that appear obvious to you. Unfortunately, however, computers can't read the English, so what the program aims to do is to translate these words and numbers and symbols you've written into a form that the computer can understand, ones and zeros. That is called compiling, and that's where a lot of the issues can occur, but don't worry, errors made during compiling are very easy to pick up on. In order to compile your program once it's been written, there are two ways of doing this: compile and download program and compile program. Compile program merely compiles the code but doesn't do anything with it. It doesn't download it to the NXT. So really you only use that if you want to make sure you don't have any compiler errors. Compile and download, however, actually installs it to the NXT brick. It installs it as a program that you can select in My Programs. It also brings up a debugger window on your computer that allows you to debug the program. However, you are free to take out the NXT at any point and run the program anywhere you see fit. It's downloaded, so you can run it anywhere without the computer. Of course, if the debug is still open and you disconnect, it will show a couple of errors, but don't worry, that doesn't indicate any permanent damage. It just merely says, hang on, where did the NXT brick go? But don't worry, that's perfectly fine. So now, with ROBOTC all set up, let's get to coding. File, new file, and you should get this. Task main is where everything happens. That within these two curly braces, that's where all of the program that you write is going to happen. You don't write it anywhere outside there. You don't mess with whatever's written here. Everything you write should be between these two curly braces. Now, that isn't entirely true. There will be variables and other tasks that you define elsewhere, but variables are very easy, and tasks, they're outside the scope of this, but feel free to investigate them if you will. They're a very powerful tool that allows you to multitask. But anyway, let's get to the basics of programming. Programming works like this. It goes through the lines of code one by one. Line 1, then line 2, then line 3, until there are no more lines to run, in which case it shuts down. So that's its logical power. It does things in a clear, concise fashion. 1, 2, 3. Pretty easy, huh? Yeah, it is. Now let's get to the other parts, because unfortunately you need to understand what the computer expects of you. You can't simply type robot drive forwards. The computer goes, hang on, I don't speak English. I don't understand what any of this means. You need to speak to it in the language it understands. It's programming language. Programming language is made up of hundreds of variables and functions that you need to learn and understand in order to use it. That instead of saying robot drive forwards, you would have to write motor. Motor A equals 100. But what does that mean? Simple. It effectively tells motor A to set its speed to 100. So, like you said, you've got to understand what you're doing here. If your robot was driven by one motor, that would be fine, but if it had a dual system, you would have to say motor B equals 100. Now, a greater investigation in how motors work will be covered in later sections, but for now, we're just going to work with this to really signify how the code works. Motor A equals 100. So it really effectively says, this motor section says, okay, find the motor. Then this section says what motor to actually control, and then this is to set how fast you want it to go, 0 to 100. Now, Of course, you know how I said it does it line 1 by line 2 by line 3? How does the computer know when a line's ended and it should go on to the next? You'll be thinking, hey, it's pretty obvious. It'll just be the next line down, right? Not exactly. Some lines can span across multiple lines, and that gets pretty complicated too, but actually, well, not really, but generally it expects a semicolon at the end of each and every line. That it takes the semicolon as, hang on, this is where I stop, time to move on to the next. And so by each and every line. Now, not all lines need to end with a semicolon, however. If, while, and various other control statements will not have a semicolon at the end of it, it will actually go pretty wrong if you do, but as a general rule of thumb, put a semicolon at the end of everything unless you know not to. So let's get back to what I talked about earlier with functions and the like. Now, you know how I said that there are hundreds of thousands of them? Don't get worried about that either. You don't have to learn all of them. This is where one of your greatest tools and resources comes into play. The help section. This has pretty much everything you'll ever need to know about programming in ROBOTC all in this one section. It'll teach you basic things about programming with ROBOTC and how it works, as well as the various commands that the robot takes, such as motors, sensors, the display, how to use the buttons, interfacing with the battery. Everything you ever need is shown here. So what is a function? A function is pretty much, it's a little section of code that tells the robot or computer to do something. Of course, it takes in various variables. So if we move into the motors section, let's go back to what we talked about earlier, the motor. It effectively says, motor contains the motor power or speed level of the motor. So it has a couple of descriptions. So you have motor, that's the function, what motor it controls, then that's one of the variables. Now variables is another interesting part. You have functions which run the code, but you have variables which tell the functions what to do. Variables are numbers or letters that are stored in a section of the computer's memory. And they're provided to it, and you can also set variables to stay throughout your program that you can manipulate at will. So, like I said, there's the function motor. The variable tells it what motor to run. It could be motor A, motor B, motor C, as well as the speed value it needs to give it. 100, 50, negative 100. The choice is yours. So, let's also talk about how to get to set up ROBOTC to work with your NXT brick. Now, your NXT robot can have various motors and sensors that you need, that the computer needs to know in order to better communicate and understand with it. That they're not exactly necessary, but they can make your life a lot easier if you do it. So you go to Robot, Motors and Sensors Setup. And with the NXT, you have the 3 motor ports and the 4 sensor ports. And this really tells you all you need to know about it. So for motor A, B, and C, you can give them little names such as drive motor or tool motor, which can prove very useful because instead of having to refer to it by motor A or motor B, you can refer to it by these names instead, which makes coding a lot easier because it makes everything easier to pick out. You can also set it whether it needs to be reversed, so any speed values are automatically reversed, which proves very useful for motors that go in the wrong direction. Then you have sensors, which really, like I said, more helps you understand it. So you have the sensor ports, you give it a sensor name like touch sensor or distance sensor, all those kinds of things. You also get to set what type it is, which proves very useful in helping you understand and organize it all. So it could be a touch or it could be a sonar sensor, and the names may differ, and it also provides sensors that aren't available to you at this moment, but it should be pretty obvious about what it corresponds to. Sound sensor, a touch sensor, that sort of stuff. And so it automatically just generates this little code that you don't need to worry about. Don't touch it, it'll be perfectly fine on its own. And yeah, that's how it works. But hang on a second, what's this? This appears to be normal English. Code automatically generated. What does this mean? That section there isn't code. And this brings me on to one of the biggest friends you're ever going to have when programming. You may think that this is worthless, but trust me, your life will be so much better if you use this. Comments. Comments are sections that aren't actually code. The computer doesn't care about it, doesn't recognize it, but it just appears there. And so you can type whatever you want into it, and the computer doesn't care about it, but you get to see it. And so it's very useful because it tells you exactly what a section needs to do. Like, if you were going through your code back again and you didn't really get it and you needed to help understanding it, do you really want to go through motor A equals 100? You go, hang on, what does this bit do again? Like, it's very useful if you've been away from it for a while, or you need to give it to a friend to work on it, and you don't want them going for 5 minutes asking you, hang on, what does this thing do? What is that? So that's where comments come in, which allow you to effectively state, this sets the motor to go forwards, which is very, very useful. But how do you signify a comment? Well, the first method is 2 double slashes. And that effectively says to the computer, anything on this line is a comment, disregard it. But what if you have more than one line? That could become an issue. So that's where you have this, a forward slash, then an asterisk. And that effectively says anything after that is considered a comment. And so that can go across multiple lines, and it only stops when you do asterisks forward slash. So anything between these two symbols is a comment. And so it doesn't have to go across multiple lines. It could be on one line, like this. Like I said, always add comments to your code so you clearly understand what you're doing, how it all works, and that sort of stuff. Let's get back to what I previously said about variables, and about how I said that you could store them as values that are used throughout your program. Now, there are various different variables that you can use, a lot of which you're not going to. But for now, let's focus on 3 main variables: string, int, and bool. What do those mean? String stands for various characters, so text. Int stands for numbers, and bool stands for a boolean value, true or false. To define a variable, you first have to state what the variable is. So in this case, we're going to declare a string variable. Now, but what is a variable going to be called? A variable is effectively a little container that you store a value in. You can put a new value in, you can read it, you can change it, you can do whatever you want to it, and the program just holds it there for your code to use. But of course, the container needs a name. So at this point, we're going to call this string text. Text. It could be anything you want. It could be display message, or it could be text display. Anything you want it to be. I recommend at this point taking upon a convention. Conventions are pretty much, they're not necessary, but they can be useful. Just the way you put everything throughout a code. Everything you do, follows a format, follows a standard, so you can clearly understand what you're working with. My standard is that I try to sort of put what the variable is in the name. So for string, I put a undercase s before doing it, so it would be s text. But let's just for now work on test string. So we've declared the variable, but we have to give it a value. Well, not really. You can just leave it here like that. Just put a semicolon and you've declared it. So you've declared the container, but you haven't put anything in it. This can be useful, but other times you need to set a value. at which point you go test string equals one equal sign, and that's going to come into play later on. So just one equal sign and whatever you want it to be. But you don't just simply write the text of hello world, because the computer gets confused because it's thinking, hang on, hello world, that's not a program. It tries to think it's a command to be read. So it throws a lot of errors when you try to do this. You need to specify that anything within these two is a string, not code to be run, but a value to be stored. So you have to put it between two double quotation marks. Hello world. And as you see, it the ROBOTC program shows it puts it in red, so you see what's a string and what isn't, instead of like a standard grey text. So let's go on to integer. An int is a number, so it can be any number you want it to be, so 5 or 6 or 150, but that's where the limit comes in. Integer values cannot accept decimal points. You can't put 55.9, that throws an error. In order to do that, you have to utilize doubles and float values, which may be outside the scope, but if you look at the help page, that'll tell you everything you need to know. So it's just a number, 55. Then you have bool. Bool stands for boolean, which means that there are two states it can be, on or off, like a light switch. So it can be, so a bool value such as, let's just call it state, it can be equal to true or false. Those are the only two options. You may think that that's not useful, but it does come into play with some programs you need to do. So yes. But how do you using these variables, you can use them and reference them throughout your code in order to do what you need them to do. So in this case, it would just be in order to reference test. So let's say, however, we need to make a new variable. You don't have to make variables here. You can make them throughout the code. So I can make a new variable here called integer answer. And it doesn't have to get a value. It can just be left like that. But what if we wanted to give it a value? It could be any value, such as 99. But for this example, I'm going to teach you how to reference it. So what if we wanted it to be 5 plus this value here? Well, you would just write it down like this. 5 plus number, and it'll go, hang on, this is a string, this is a number variable, so I'll work with it accordingly. And this brings me on to another important topic, making sure that you give it the right name, because like I said, it understands that number is a variable because it checks back and says, hang on, there's a variable called number, so obviously it's a variable. But what if I was to give it another name, such as, oh, I don't know, motor? The computer gets confused. It goes, hang on a second, mode is a variable, but it's also a function. What is the person talking about here? Does he want me to talk about the function or the variable? It gets confused. So that's why you need to make sure you don't use that as a variable name. You need to ensure it's a unique thing that isn't used by the computer. This is where conventions come into play. Like, for example, by putting I before everything, it makes sure that it doesn't get mixed up with a function. There is no functions that start like that. This concludes today's video on setting up ROBOTC and basic programming. If you need help with anything, then I recommend checking the help pages. Sometimes searching on the internet can also be useful, but if it doesn't work out and your question is unanswered, send me an email at my email address that I'll show you below. The email address is shown in the description. Thank you for watching, and more videos will come soon on various different topics that aim to teach you about programming. Goodbye.